equations. So one maybe is an x squared term while the other one is a 10y squared term, but they're both positive, just different numbers in front. With hyperbolas, we want to have two squared terms, but they have to be different signs. So it doesn't matter if the number is the same, but one of those squared terms has to be positive and one of them has to be negative. That's what indicates that we have a hyperbola. And then parabolas, we actually only have one squared term. So when you start looking and you only count one of them as a squared, automatically it has to be a parabola. So let's take a look at these four different equations and let's identify what conic they are. In the first example, we have 16x squared plus y squared minus 64 equals 0. So the moment I see that there are two squared terms, I know that it's not a parabola. Notice that 16 is a positive number, and technically in front of that y squared is a 1. So we have two different numbers, but they're both positive. That is going to indicate that we have an ellipse. In the second example, 16x squared plus y minus 64 equals 0. Right off the bat, I'm only seeing one squared term, and so that means that we must have a parabola. In problem number 3, we have a 16x squared minus 16y squared minus 64 equals 0. So I have two squared terms, and one of the numbers in front is a positive while the other one is a negative. That indicates that we have a hyperbola. And then here in the last one, we have 16x squared plus 16y squared minus 64 equals 0. I see two squared terms, I see both positive terms, and I see the same number in front. That means that we have a circle. All right, so that was classifying. Now let's do the other concept. Let's write equations in general form. So, like I mentioned, general form is when every single term is to one side and it equals 0. So if we start with standard form, let's go through the steps on how to get it into that general form. When you have standard form, chances are you're going to see some fractions. Remember, ellipses have fractions, hyperbolas have fractions. So if you see any fractions, what we want to do is we want to find a least common denominator, and then we're going to multiply both sides of the equation. So essentially every single term by that LCD, because then that will eliminate fractions. If we have terms that have parentheses and it's quantity squared, we have to multiply out those terms. General form doesn't have any parentheses, so that's why that's our next step. We want to eliminate those parentheses, which involves us doing some multiplying. Obviously, then we have to make sure that it equals 0. So we move everything to one side so we can get that equation to equal 0. So let's take a look at some examples to follow these steps. Here, if I want to write the conic in general form, the first example we have is x squared over 49 plus the quantity y plus 1 squared all over 16 equaling 1. So as you can see, we are having it in standard form. This is technically an ellipse. Notice how there are denominators here, and I want to get rid of those fractions. So between 49 and 16, at the end of the day, if you can't recognize that they have a number in common, remember, in order to get rid of your denominator, you have to multiply at least by the bigger denominator. So 49 is bigger than 16. We would have to multiply by at least 49. But to get both of those numbers to go away, if you can't figure it out, just multiply those two numbers together. It might not necessarily be the least, but at least it's a common denominator. And so if I multiply those two together, I get the number 784. So that means I'm going to multiply every single term by that number 784. Because then I know 784 divided by 49 is going to give me 16. So that's why technically only now 16 is multiplied by that numerator, x squared. Plus, because I know that I got 784 by multiplying 49 and 16, 784 divided by 16 is going to be 49. That is going to be multiplied by this numerator, y plus 1 quantity squared. That is going to equal 784 times 1 is 784. Now, 16x squared, we're not going to be able to do any type of multiplying. There's no parentheses there, so that gets to stay as it is. The second term has parentheses, so I'm going to leave the 49, but I want to think about a quantity squared as being multiplied by itself twice. I'm going to actually go ahead and multiply out those two binomials, and then we'll take care of the 49 at the end. Y times y is y squared. Y times 1 is 1y, but I have two of those. And then 1 times 1 is 1. Now that I've gotten rid of the two binomials and I have now a trinomial, I'm going to distribute that 49 to each of those terms. 49 times y squared is 49y squared. 49 times 2y is going to give us a positive 98y. 49 times 1 is 49. I'm going to go ahead and I'm going to move that 784 to the other side. I would have to subtract it, so then I can get that equals 0 that I'm hoping for. At the end of the day now, all the parentheses are gone and there's no fractions, so it's just a matter of combining like terms. Well, the only like terms that I have are going to be those numbers here at the end. And 49 minus 784 gives us a negative 735. That equals 0. And notice that this is the general form that I'm looking for. All the terms are to one side. There's no fractions. There's no parentheses. And so we're done. If I take a look at this next example, negative 1/2 y equals the quantity x minus 2 squared. I want to get rid of the fraction first. So I'm going to go ahead and I'm going to, since that's the only fraction, I'm going to multiply by that denominator, which was 2. So if I multiply every single term by 2, negative 1/2 times 2 is going to give us just a negative 1 with that y. We then still have 2 times that set of parentheses. Now I'm going to write it out twice, similar to what we did in the last example, because I want to go ahead and I want to distribute. So I'm going to keep the 2, but now I'm going to multiply the binomials. X times x is x squared. X times negative 2 is a negative 2x, but I have that twice. So I'll have a negative 4x. Negative 2 times negative 2 is positive 4. I'm going to go ahead and distribute that 2. So we'll have a 2x squared minus 8x plus 8. And then the last step is I want to make it equal 0. So I'm going to move that y over by adding. So we're going to have a 2x squared minus 8x. I'm going to put that y term next. It's a positive y. And then I'll put that number last. Here is my general form for that. And notice how that one was a parabola. So here's the general form of this parabola. Let's take a look at one more. Notice that I see a fraction. There's only one denominator, so that means that pretty easy to find that common denominator. I'm going to multiply every single term by 9. So 9 is going to get multiplied by the set of parentheses y plus 2 quantity squared, which I'm going to go ahead and already write out as y plus 2 times y plus 2. Because it's a subtraction sign, remember that means that this was a hyperbola. When I multiply that 9 by this fraction, the 9's are going to go away, and I'll just have that x minus 1 quantity squared. So once again, I'm going to write that out twice. This is going to equal 1 times 9, which is 9. All right, got lots of multiplying here. I'm going to multiply the first two binomials. y times y is y squared. We'll have y times 2, so that's 2y, but we'll have that twice, so that gives us 4y. 2 times 2 is 4. Minus, now in the next set of parentheses, x times x is x squared. X times negative 1 is negative x, but we'll have that twice, so we'll have a negative 2x. Negative 1 times negative 1 is positive 1. This still equals 9. I'm going to distribute that 9, so we'll have 9y squared plus 36y plus 36. Notice that I had kept that x terms, that trinomial in parentheses, and that's because we have a negative. I'm going to distribute that negative. So we'll have a negative x squared plus 2x minus 1. I'm going to go ahead and subtract that 9 over to the other side, so I'll put minus 9, and this equals 0. Now it's a matter of just combining like terms and getting it into that general form. General form, I want the x squared term first. So I'm going to have a negative x squared. Then I want the y squared term. So we'll have a plus 9y squared. Then I'm going to put the x. There's only one of them. So we'll have plus 2x. If I look at everything, I only have a single y term. So we'll put plus 36y. But then as you can see, we actually have several numbers. So I want to go ahead and I want to combine all of those. So we're going to add 36 minus 1 minus 9. That's going to give us a positive 26. This equals 0. This is our standard form, or sorry, not standard, general form from the standard form of this hyperbola. So that's what I wanted to get through. We can now classify a conic given general form, and we can rewrite from standard form back into general form.